Get ready for a cosmic event so colossal, so awe-inspiring, that it could forever alter the way we look at the night sky. A ticking time bomb, located over 600 light-years from Earth, is sending out signals, warnings perhaps, that its end is near. That star is none other than Betelgeuse, the red supergiant that has both fascinated and mystified astronomers for centuries. Recently, this massive star has begun behaving very strangely. Its light has fluctuated in ways never seen before, and scientists are growing increasingly concerned. Data gathered by cutting-edge instruments like the James Webb Space Telescope and the Hubble Space Telescope is painting a picture of a star in turmoil. Prominent physicist Brian Cox has gone so far as to issue a public warning: we may be about to witness something truly historic, a supernova explosion so bright and so violent, it could cast shadows on Earth and remain visible in our sky for months, even during the day. But what is Betelgeuse? And why is it so important? To truly appreciate the significance of what might be unfolding, we need to understand the life and death of stars. Stars are born from clouds of dust and gas, ignited by gravity and nuclear fusion. They live out their lives producing energy by fusing hydrogen into helium, eventually moving on to heavier elements. But when a star runs out of fuel, its life ends in one of the most spectacular and violent ways imaginable. Betelgeuse is a red supergiant, one of the largest types of stars in the universe. Located in the shoulder of the constellation Orion, this star is a staggering 900 times larger than our Sun. If we could somehow replace the Sun with Betelgeuse, its surface would extend past the orbit of Mars, swallowing up Mercury, Venus, Earth, and perhaps even reaching the asteroid belt. Its sheer scale is difficult to comprehend. This enormous size means Betelgeuse is nearing the final chapters of its stellar life. As a red supergiant, it's already exhausted its core hydrogen, and is now burning heavier elements. This phase doesn't last long in cosmic terms, just a few 100,000 years, or less. And when it ends in a supernova explosion of almost unimaginable scale. Astronomers estimate that Betelgeuse is somewhere between 8 and 8.5 million years old, a middle-aged red supergiant. Unlike smaller stars that live for billions of years, massive stars like Betelgeuse burn through their fuel much more quickly. That's why its age, though relatively young in stellar terms, already places it close to its expiration date. Betelgeuse's color is one of the first clues to its condition. Its deep red hue, visible even to the naked eye, indicates a cooler surface temperature, about 3,500 Kelvin, much cooler than our Sun's 5,500 Kelvin. This color isn't just aesthetic, it tells us the star is in a late, unstable phase of its life. Ancient observers noticed this too. In fact, historical records reveal that the color of Betelgeuse has changed over time. 2,000 years ago, Roman and Chinese texts describe it as yellow. By the 9th century, Arab astronomers described it as red. This change suggests a slow and steady transformation in the star's temperature and structure, something that matches our modern understanding of stellar evolution. Betelgeuse has been aging before our very eyes for centuries. Another fascinating aspect of Betelgeuse is that it's a variable star. Its brightness naturally rises and falls in a somewhat predictable pattern. It has a primary cycle of about 400 days, and a secondary cycle that lasts roughly 5 years. Ancient civilizations, including indigenous Australian peoples, noted these variations long before modern astronomy could explain them. But then came the Great Dimming, an event that defied expectations and sent shockwaves through the astronomy community. In late 2019, Betelgeuse began to dim. Not just a little, but dramatically. Within a few months, it had lost more than 2/3 of its brightness. By February 2020, it was barely visible to the naked eye, even in areas with little light pollution. People around the world who knew where to look could tell that something was wrong. The familiar red shoulder of Orion was fading, becoming a ghost of its former self. This event sparked an avalanche of questions. Was Betelgeuse collapsing? Was this the beginning of the end? Were we on the verge of witnessing a supernova in real time? Unfortunately, observing stars in real time isn't as straightforward as it seems. Because Betelgeuse is 654 light-years away, we see it as it was 654 years ago. The light we observe tonight actually left the star in the 14th century. If Betelgeuse exploded today, we wouldn't see the supernova until the year 2679. This time lag adds a strange and haunting mystery to our observations. Are we watching a star that's already gone? To find answers, scientists turned to the Hubble Space Telescope and later, the James Webb Space Telescope. A team led by Andrea Dupree at the Harvard-Smithsonian Center for Astrophysics conducted a detailed investigation. They discovered that Betelgeuse had expelled an enormous cloud of gas and dust from its southern hemisphere, material moving at 200,000 miles per hour. This ejection likely formed the dust cloud responsible for the dimming. Essentially, the star created its own foggy mask, blocking its light from reaching us. What's even more incredible is the scale of this ejection. The mass of material lost during this event was at least twice as large as any previously recorded mass loss episode from this star. Such a violent outburst may have been caused by a surface convective plume, a giant cell of hot plasma rising from deep within the star. As the plume broke through the surface, it may have destabilized the outer layers, releasing a cloud that extended millions of miles into space. While this explains the great dimming, it doesn't answer the most pressing question: is Betelgeuse about to explode? A supernova of Betelgeuse's magnitude would be unlike anything anyone alive has ever seen. When it happens, whether next year or 100,000 years from now, it will shine as bright as a full moon. For several weeks, the explosion could be visible even in daylight. It would cast shadows at night, be studied by every telescope on Earth, and provide a once-in-a-lifetime look at a dying star. Despite the excitement, most scientists agree that Betelgeuse isn't immediately about to go supernova. It could happen tomorrow, or in another 100,000 years. We just don't know. What we do know is that its behavior is becoming increasingly erratic, its mass loss is accelerating, and its brightness cycles are no longer consistent. All signs that something unusual is happening deep inside its fiery core. There are several theories about what comes next. Some believe that the star will continue to dim, brighten, and fluctuate until its core finally collapses. Others think the recent outbursts are simply part of a chaotic but natural aging process for a red supergiant. A few believe we are witnessing the pre-supernova phase, the final unstable years before the inevitable collapse. Whatever the truth is, we are witnessing history. Humanity has never observed a star like Betelgeuse in such detail during its final stages. It's a front-row seat to one of nature's greatest and most violent shows. So what does this mean for us on Earth? Thankfully, Betelgeuse is far enough away that its supernova poses no danger to life here. The radiation will be spread out and won't affect our planet. But visually, it will be a stunning phenomenon, one that will inspire awe, wonder, and probably a little fear. It will remind us that the universe is alive, and that stars, like everything else, have a beginning and an end. Whether Betelgeuse explodes in our lifetime or not, we are lucky to live in an age where we can observe it so closely. With every telescope pointed at the Orion constellation, we're not just studying a star. We're witnessing the heartbeat of a dying giant, and waiting for that final, brilliant pulse.